Okay, fine. So let us take. I'll give you some bunch of questions. So we have to attempt question number one, and then we have to attempt say question number two. So these are the two questions, and I'll give you 4 minutes for the same. So we have 4 minutes, and you need to attempt these two questions. Only focus on these two questions, and also at the end of your attempt, we'll discuss that which question should have been solved first and which question should have been taken later. Right? So your time starts now. Please start. Here one more, there is information that both these all these three value x, y, and z are perpendicular on the side of the larger equilateral triangle. So this information was missing in the question. Okay, without wasting time, I'm just going to solve question number one. I think this question should have been taken first and then the question number two. So it says that we have an equilateral triangle. So let me name it that the equilateral triangle is say ABC, and the smaller equilateral triangle has let me name it PQ and R. And these are the perpendicular from the vertices of the smaller equilateral triangle on the sides of the larger equilateral triangle. It also says that the side of the smaller equilateral triangle is of length 1, and side of the larger equilateral triangle has a side root 3 plus 1. And one more information given to us is that these the sides of these two triangles are parallel. So that means this is parallel to this, so as this is parallel to this, and this is also parallel to BC, right? So how to approach this question? This question can be solved easily if we know the one information for equilateral triangle, one end result for the equilateral triangle, and that is in any equilateral triangle, if you take any point inside the equilateral triangle, and if you want to add the perpendicular distance of this point from all these sides. So suppose the perpendicular distance are x, y, and z, then you'll find that the value of x plus y plus z is nothing but the height of the equilateral triangle. Right? Let me prove it for you. Suppose I want to join this point with all the vertices of the equilateral triangle. So I have divided this equilateral triangle into three parts, with one with triangle APB, another with triangle APC, and BPC. And if I add the area of all these three triangles, I am going to get the area of equilateral triangle, that is ABC. Correct? Now if I assume that the sides of equilateral triangle are A, then the area of APB will be, if I assume that this is the base, then this become the height. So the area of triangle APB will be half of A into x. Similarly for second it will be half of A into z, plus third one will be half of A into 1, and this should be equal to root 3 by 4 times of A square. Correct? Yes, the answer is C, 1.5 I think. So if I remove this A, I get x plus y plus z, or half of x plus y plus z, equal to root 3 by 4 times of A. So if I remove this also, this root 3 by 2 times of A is nothing but the height of equilateral triangle. I hope this much is clear clear with everybody. Yes, no? Clear? Now, coming back to the question, I can assume that this point Z, or this length Z, can be shifted at this point. This will again retain the same height. This Y can be shifted at the midpoint of here. And if I add the height of the smaller equilateral triangle and let it be h, and if I want to find the value of say x plus y plus z plus h, it will be the height of the larger equilateral triangle. Clear? So just we have to substitute the value. So x plus y plus z plus height of the smaller equilateral triangle will be root 3 by 2 times of 1 because the side is 1, and here it will be root 3 by 2 times of root 3 plus 1. So after some substitution and other things, you'll get that the value of x plus y plus z is 3 by 2, which is 1.5. So the answer is option C. Clear? Okay, let me move to the next question, otherwise we'll have less time. Okay, now here comes the very good question. uh, how many of you got the answer? Yes, Bhomik, you can take that because nothing has been mentioned about the relation between x, y, and z, so you can take the midpoint of it also. Okay, I got only one answer for this question. Or in fact, one person give me the answer. Now it's a very good question. Let me start with the solution. Now it says that ABCD is a square and whose area is equal to the area of triangle FAE also. So that was the thing. It says that the area of the square ABCD is equal to area of the triangle AEF. Correct? So if I look at the figure, I can say this particular part is common to both square as well as the triangle. Fine. So I can say that the extra part which is outside the square, or this part and this part, the area of combination of these two triangle must be equal to area of this part of the square. I hope everybody agrees with me, right? If the area of triangle is equal to area of the square, then the area of this two triangle must be equal to area of this part. Correct? Okay. The other thing is that all these three triangles are similar triangles. It can be easily proved. Say this angle is equal to this, and this is 90 degree, so as this angle. If two angles are equal, then the triangles are similar. Similarly, in these two triangles, you can see that this angle x is equal to this angle. Angle B is 90, so as angle C. So I can say that all these three triangles are similar, or I can say that the triangle YDF is similar to triangle YCX, which is similar to triangle XBE. I might be missing the order in which I should have written, but the main objective is that all these three triangles must be similar. Clear? Apart from that, we know that the area of this triangle, let me mark it, or let me say that the area of this triangle is delta 1, and the area of this triangle is say delta 2, and area of this triangle is delta 3. So we know that delta 1, or the area of this triangle, is equal to delta 2 plus delta 3, right? We also know that if the two triangles are similar, then the ratio of their area is equal to the square of their corresponding side. Clear? So I can say that if I compare these two, if I take these two triangles, that is delta 1 and delta 2, so area of delta 2 over delta 1 can be written as x square by 7 square. Is this part clear? Because this is the critical point. Please respond if you are clear with this. I am taking the corresponding side. Okay, fine, great. So if this part is clear, then you can understand the rest of the part. Similarly, for these two triangles, I can say that delta 3 over delta 1 will be equal to it will be 6 square by 7 square. Guys, everything is given here, right? This side is 7, this side is 6, right? Because the entire part is 13. That is given in the question, that the length of the side square is 13. Clear? Now let me add these two things. Let me add this ratio and this ratio. So what do I get? I get delta 2 plus delta 3 upon delta 1 equal to x square plus 6 square by 7 square. I hope this part is also clear, everyone. Please be active and respond so that I can move ahead. Correct. Now from this relation we know that delta 2 plus delta 3 is equal to delta 1. So I can say this particular ratio is actually 1, or I can say that this ratio is also equal to 1. So straight away I can write that x square plus 6 square by 7 square is equal to 1, or x square plus 6 square is equal to 7 square, or x square is equal to 7 square minus 6 square, which comes out to be 13. So the value of x is root 13. This is the solution. We go for question number 4 first. It says that it's an octane. Octane in the sense is the 1/8 part of the circle. So what will be this angle? What will be the angle AOD? It will be 45, right? Okay. So this will be a 45-degree angle. Clear? Apart from that, we have been given that ABCD is a square, is a rectangle, and AD is 6. So if AD is 6, I can say BC is also 6, right? Similarly, if AB is 2, then DC is also 2. Now observe the triangle OAD. If you look at this triangle, this angle is 90, this is 45, so this is also 45 degree. So it's an isosceles triangle, isosceles right angle triangle. So I can say that the length of OA is also 6. Correct? Guys, please respond that have you got this thing or not? That OA should be equal to 6. Fine? Okay, great. Now the answer, now the question is correct. If I join OC, it will be the radius. Yes or no? I'm joining from the center to the circumference. So this will be the radius. So in triangle OBC, it's an also a right angle triangle. Right angle at B. Fine. So if you apply Pythagoras theorem in this triangle, your answer is done. So OC square will be 6 square plus 6 plus 2, which is 8 square, and we know that 6, 8, 10 are the triplets. So straight away the value of OC is how much? 10. Fine. So area of the it has been asked that the area of the octane. So area of the octane will be 1/8 part of pi into 10 square, which comes out to be 12.55. So this is the right answer. Right. Let me go with the normal method, and then we will figure out whether it is cyclic or not. Okay? Because there is another question in which it's a cyclic quadrilateral. Anyway, so let me draw this figure. So if I take P S as 25, and it says that PQ is 5, QR is 17, and RS is 7. It also says that the angle this, let it be angle Q, and this angle the angle R. So we know that angle Q plus angle R is 270 degrees. This part is given, and all the four sides are given. So prima facie it will be difficult to prove that it's a cyclic quadrilateral, although my assumption might fit with the answer, because in cyclic, what is the cyclic quadrilateral? In any quadrilateral, if the opposite angle, the sum of the opposite angle is 180 degree, then we call it as a cyclic quadrilateral. Right? Atanu, how did you get that it's a cyclic quadrilateral? Can you just throw some light? Okay, so that's what I mean to say, that if you make the assumption that it's a cyclic quadrilateral just to solve this question, then it can be solved. Let me just give you the solution. So what I'm doing here is that I'm basically getting hint from this number 270, because the full circle is 360. If I subtract 270, it's 90 degree. Apart from that, these numbers 7, 5, 17, 25, these all numbers are used in triplets, right? 5 we use in say 3, 4, 5 cases. We use also that 5, 12 and 13. For 7 we use 7, 24, 25. 25 is also one of the numbers. 17 we use 8, 15 and 17. So these are the numbers which actually frequently appear in a triplet. So I'm just trying to make some kind of arrangement out of this, right? So what I'm doing here is that if this angle this plus angle this is 270 degree, if I extend this line, and if I extend SR, it will meet some point say T. Now this line is 17. I'm just trying to find out whether this angle is 90 or not. Clear? So say this angle is x and this angle is y. So you can see that angle x plus angle q will be equal to 180 degree because it's a straight line. Similarly, angle y plus angle r is equal to 180 degree. If I add these two, it will be x plus y plus r plus q is equal to 360 degree. Now q plus r, we know that it's 270 degree. So therefore the value of x plus y alone will be 90 degree. Is this part clear, everyone? Please respond. Okay, fine. So I can say that in triangle TQR, these two angles, the sum of these two angles x and y is 90, hence angle T is 90, because sum of all the angles in a triangle should be 180 degree. I hope this is clear now. Clear? And let the side TP be A and TR be B. So applying Pythagoras theorem in these two triangles, that is in triangle TPR, will get that it's A square plus B square is equal to 17 square, and in the triangle say T, it will be TQR, sorry, right? And in the triangle TPS, you'll get A plus 5 whole square plus of B plus 7 whole square is equal to 25 square. Yeah, well, I'm writing you. If in case if you are finding it difficult, please refresh your page. Fine. Now we have to solve these two questions to get the answer of value of A and B. But if you try to fit the triplets, it will be very easy because this triplet should fit. So by some hit and trial, I can say that if I take the value of A to be 15 and B to be 8, I can manage both this equation. This much is expected from anybody who want to score well in quant, because you don't have to solve every time. You should be good enough to fit the previously known values. Correct? Once you got the value A and B, now the answer for this answer of getting the area of this quadrilateral can be answered. What you can do is you can find the area of the larger triangle, which is a 90 degree, and the area of the smaller triangle, which again is also 90 degree, and you subtract that. So if you take the area of triangle TPS, it will be half of TP, which is 5 plus 8, and A is 15, so TP will be 20, so it is 20 into TS, and the value of TS, if I take the value of B to be 8, will be 15, minus half of this triangle, which will be half of A, which is 15 into 8. If you solve this, you will get the answer to be 90. That is option B. Okay, I'll quickly solve it in the separately, right? Just go through it. I'll quickly do it. So what we had is, we had PS as 25, then we had PQ as 5, R as 17, and PS as 7. So what we did is, we expanded this, and this plus this angle is 270 degrees. So we found that this angle plus this angle is 90 degree. Therein we found that this angle should be 90, right? So area of this part can be found by subtracting area of triangle TPS with area of triangle TQR, right? Now let me take TQ as A and TR as B. So applying Pythagoras theorem in this triangle, I can say that it is A square plus B square is equal to 17 square. Similarly, applying Pythagoras theorem in this triangle, I can get that A plus 5 whole square plus B plus 7 whole square is equal to 25 square. Correct? Solving these two by substituting the triplets, you can get the value of A to be 15 and B is equal to 7. Fine. Now apply the area here. So area of TPS, if I assume this to be the base, this will be the height because this is 90 degree. So it will be half of a plus 5, which is 20, into TS, which is b plus 7, which is 15, minus half of area of this triangle, which is half of, say, a is 15 and b is 8. So if you solve it, you will be getting half of 15 into, I think, 12, right? Half of 15 is common, so if you solve this, you will get the answer to be 90. Now is it clear, everyone? Okay, fine. Now let's get back to the fourth question. I think we solved the fifth one. Now, okay, sorry. The question number 3. Yet again another question. Guys, please remember that such kind of questions have appeared in CAD. I have written CAD almost 10 times, and I have found that in the recent online tests, such kind of folding and other part of questions have appeared a lot, right? So do pay attention to such questions. Okay, so in this question, what we have been given is that a rectangle has been folded along the diagonal such that it makes this pentagon, right? And the area of this pentagon is 7 by 10 of the original rectangle. Now we have to find the ratio of the length and width of the sides of the rectangle. Clear? Now if you observe, so let me take it that this is A, B, this is C, and this is D. You can see that if I unfold it again, this position will be C, or let me call it C dash. If I had folded it, this point has coincided with this point. Yes or no? Right? And BD was the diagonal. If this angle is 90, this angle will also be 90 degree. It's a very symmetrical figure. Clear? And say this part or this point is E. So I can say that after folding, the area of triangle DEB has been overlapped. Yes or no? Is this part clear? That this area has been overlapped, and that is the reason the area is less than the area of the original rectangle. Clear? Now if I assume that the area of original rectangle to be 1 and the area of this part is 7 by 10, then the balance will be 1 minus 7 by 10, which is 3 by 10, should be the area of triangle DEB. Is this second part clear? Because of the overlap, we lost the area. So whatever has been the loss should be the area of the overlap part. Clear? So I can say that the area of this part is 3 by 10. Also, the balance parts of this pentagon, the area of the balance part will be 3 by 10 minus 7 by 10 minus 3 by 10, which is 4 by 10. That should be equal to area of this triangle plus this triangle. And with symmetry, I can say that these two are congruent. I do not need to prove it. Even if you want to prove it, you can go ahead with this thing that this angle and this angle is equal. Okay, this side will be equal to this side. So since these two are similar as well as the corresponding side is equal, hence they are congruent. If they are congruent, then the area will be equal. Yes or no? So I can distribute the balance area in two equal half, that the area of this portion will be 2 by 10 as well as this part also. Till now everybody is with me? Please respond. Okay, fine. So now we have done with the solution, right? Apart from that, triangle DEB will also be symmetrical. So I can say that this, in fact, we have proved that these two triangles are congruent. So the corresponding sides will be equal. Now let me take that this, just observe triangle DCB. Just observe this triangle. So if you observe that in these two triangles, the or I can say that DCB is equal to triangle DCE plus triangle DEB, right? If I consider CE and EB as the base of these two respective triangles, this triangle and this triangle, then I can say that the height DC will be same for both. Yes, no? If I consider this CE and EB as the base, then height for both these triangle, if I consider this as the third vertices, will be same, because DC itself is perpendicular on CB. Guys, please respond. Right? So if we have two triangles, something like this, and their base is x and y, then their area, the height is same, then their area would be in the ratio of their base, right? So area of this triangle with this triangle will be the area of their respective bases, because the height is same. So I can say that the area of triangle DCE over triangle DEB will be equal to CE over EB, which effectively the area is what, 2 by 10 and 3 by 10. So this is equal to 2:3. Is this part clear? Fine. So CE and EB are in the ratio 2:3. So let me assume that CE is 2x, or let me just change the color of. So if I assume that this to be 2x and this to be 3x, this will also be 3x, this will be also be 2x. Clear? Now apply Pythagoras theorem in this triangle. If we apply Pythagoras theorem, you'll find that DC square, that means the value of this part, will be equal to 3x whole square minus 2x whole square, which is equal to, it will be 9x square minus this, so 5 of x square. Or I can say that DC is under root of 5 times of x. Clear है यहाँ तक? Fine. So what is the width of the rectangle? It is DC. And what is the length of the rectangle? It is BC. So we have been asked to find the ratio of the longer side to the smaller side. So longer side is 2x plus 3x, right? This is the longer side. So it will be 2x plus 3x. In fact, let me write it here. So the longer side will be 2x plus 3x, and the shorter side is root of 5 times of x. So x being common will get cancelled. It will be 5 by root of 5, or more precisely it is root of 5 by 1. So this is our final answer. Guys, please remember, it is not that difficult as it the time I took, but I took the time to explain you the things. Bala, because the ratio of these two triangles, we got the area of this triangle to be 2 by 10 and area of this triangle to be 3 by 10. So the ratio of the area of these two triangles should be equal to this, right? So if you substitute this value 2 by 10 and 3 by 10, you get the answer. Okay, fine. So we are done with these three questions. So let us move to the next set of questions. Okay, now I'll invite you to the questions of a different kind. Say, take up question number 7. You have to take question number 7. Question number 8. Question number 9. And say question number 11. I'm giving you a reasonably moderate difficulty level, easier to moderate difficulty level question. So these are the 4 questions. I'll give you, say, let me give you 7 minutes. That will be more than enough. So everything, whatever is given in the question, it directly say that BC is the diameter, right? and D is one of the point, D is is the another point on the circumference. So if I join D with C or E with, or B with E, they will be 90 degree, right? Because the angle in a semicircle is 90 degree. So what I am doing here is that I am drawing a straight line, or I am joining C with D, and the value given to us, that DC is under root of 901 and the value of BD is 1. So straight away the answer for DC will be 30. You can apply the Pythagoras theorem and can get the answer. In fact, 901 itself gives you a lot of hint that it's 900 plus of 1, and 1 is the value of BD. So definitely the value of DC would be 30. Fine. The next thing is, so this is 90 degree and there is one value which is dA, this is 16. Again, applying Pythagoras theorem in triangle ADC, if you apply Pythagoras theorem in triangle ADC, you'll find this is 16, this is 30, so AC would be 34. I'm using the triplet 8, 15 and 17. If I double all these numbers, I'll be getting it 16, 30 and 34. So these are the smart work which is expected. Rather than applying Pythagoras theorem every now and then, you should use the triplets. Am I clear till now? Anyone, any doubt? Please respond. Okay, fine. So again we know we have to find the value of EC. So let it be X. So the value of AE would be 34 minus X. So we know that in any circle, if we draw 2 seconds from a point outside the circle, which is P, and this point is AB, this point is C and D. So we know that the relation is PA into PB is equal to PC into PD, right? I believe everybody knows this. Okay. So applying the same thing here. Here the point P is, in the question the point is A. So I can apply that AD into AB is equal to AE into AC. Correct? The value of AD is 16. The value of AB would be 17 because it will be 16 plus 1, right? So this entire value will be 17 and is equal to AE. Let me find the value of AE directly, and the value of AC is 34. So this goes by 2 times, this goes by 8 times. So the value of AE is 8 and the value of AC is 34. So the value of EC would be 34 minus 8 or 26. So this is the answer. I hope everybody got the answer. Any doubts anywhere? Okay, fine. So let's move to the next question then. Let me take this question, question number 8. Now it says that there are two semicircles, so let me take these points. This point to be P, this the center to be Q, and it says that the radius of larger semicircle is 10 centimeter and smaller semicircle is 5 centimeter. So I can say that this value is 5. Also, if I join RP, this will also be 5, and R being the midpoint, this angle will be 90 because of the symmetry, right? Both the angles will be 90. Similarly, since the line RT is tangent to the larger semicircle, so if I join TQ, this will be radius, TQ will be the radius, and the value will be 10, and this angle will be 90. Is this part correct? Is this part clear, everyone? Okay. Now I need to find the value of RT. This is the value which we need to find, and BQ will also be 10. So what I do is I am joining R with Q, and the purpose for the same is that I can divide this quadrilateral into two right angle triangles. One is this and another is this. So that was the objective. Clear? Now the value of RQ square will be equal to RP square plus PQ square, correct? Which will be 5 square plus 15 square. Fine. Similarly, applying the Pythagoras theorem in this triangle, the value of RT square will be equal to RQ square minus PQ square. Substituting the value of RQ, it will be 5 square plus 15 square minus 10 square. So this will be 25, this will be 225, this will be 100. So it will be 150 if I am not wrong. Okay. Right. So RT square is this much. So the value of RT is under root of 150. So this is the answer. Is this clear? Shall I move ahead? Okay guys, please respond. We are into the last lap of solving the question, and I still have not taken the best of the question of this lot. Is this part clear? Guys, can you hear me? Okay, fine. So congratulations to all those people who have solved this question, right? This was the expected question to be solved. Okay, let's go ahead to the next part, which is question number 9. How many have solved this question? I got some people giving me the answer. In fact, the answer was 90, right? Yes, good. It's a right answer. 90 is the right answer. Now it says that the three squares are kept simultaneously. Three squares are kept side by side, each having side 8. Even in this question, the length is not required. So if such question can be modified, and if I don't give the length, still we can get the value of angle A plus B plus C, right? So it says that the sides are 8, and we have to find the value of angle A plus angle B plus angle C. Straight away angle C, the value is 45 because it's this length is the diagonal of this square. This is 90 degree, 45 degree, right? So I have to find the value of angle A plus angle B. So what I do is, if I consider this triangle and I want to find tan of B, it will be perpendicular, that is 8, this length divided by this length, which will be 16, or the value is half. Similarly, if I take this triangle, then tan of C would be 8 divided by 8 plus 8 plus 8, that is 24, or the value is 1 by 3. And we know this is tan of A, right? And we know that tan of A plus B will be equal to tan of A plus tan of B upon 1 minus tan A tan B, right? If you substitute the value of tan A and tan B as half and 1 by 3 respectively, you will get the value of this expression equal to 1. So the A plus B, or the angle A plus B, would be 45 degree. So sum of this plus this is 45 degree. This alone is 45 degree. So sum of angle A plus angle B plus angle C is 90. Is this part clear, everyone? Okay, fine, great. So let's move to the next question. And it was question number 11. Again, a simple application of similar triangles, you can get this area of the shaded region. You can see that this triangle and this medium size equilateral right angle triangle and the largest right angle triangle are similar, because this angle is common to all, and each of these right angle triangle has one angle as 90 degree. Fine. And this shaded region is nothing but a trapezium, wherein this length and this length are parallel sides, and this is the height. So I know the value of height, that is 3 centimeter. Somehow I want to get the value of the sum of these two sides, correct? So apply the similar triangle funda. It will be, this length will also be 5 centimeter. You can find that if this is x, So if I take the smallest triangle and the largest triangle, I can say that x upon 1 should be equal to 5 upon 5 plus 3 plus 1, which is 9. So value of x is straight away 5 by 9. Similarly, if the value of this length is y, and apply the similar triangle in the second largest triangle with the largest triangle, then it will be y upon 3 plus 1, which is 4, is equal to 5 upon 9, or the value of y is 20 by 9. We got the value of x and y, we have the height, so we can get the area, and the area is half of sum of the value which is x plus y into height, which is 3. Substitute the value, it will be 5 plus 20, which will be 25 by 9 into 3. So this goes with 3. So the answer is 25 by 6 straight away. This can be solved within a minute. I hope people have got it right. Okay guys, so let's take the next round of question. Now let me give you some really very good questions. Take up question number 13. Question number 14. In fact, there was one more question. And this question number 10. Again, 6 minutes. Okay guys, we are running out of time, so let me start with the solution, right? Please pay attention. So I am solving in that order, question number 10, 13 and 14. Okay, so the answer is 14, you need to say. Okay, fine. So how do you to solve this question? See, whenever you find any question having a value apart from the perpendicular and 90 degree, if you have value say 120 degree, 30 degree, 60 degree or 150 degree, you must use the fundamental of 30, 60 and 90 degree triangle. I hope many of you in fact all of you must be knowing this, that in any right angle triangle with 30, 60 and 90, if this is 30 degree, this is 60 degree and this is 90 degree, then side opposite to 30 degree, if the value is a, then side opposite to 60 degree, the value will be a root 3, and the side opposite to 90 degree will be 2a, or the ratio of sides opposite to these angle will be in the ratio 1 is to root 3 is to 2, correct? So what I suggest is that whenever you find these angles, you must give or you must use these things, because in most of the question application 90 degree triangles give you the answer. So since this is 120 degree, so what I do is I am expanding BA like this, similarly DC like this, fine. So this angle will be 90, this angle will be 60 degree. So this angle has to be 30 degrees. Let me take this point as point E. Fine. We know that one of the side of this triangle, the side opposite to angle 30 is 11. So side opposite to angle 60, that is ED, this length will be 11 root 3. Correct. Similarly, side opposite to 90 degree, that is EA, will be double of this, which is 22. Is this part clear? I am applying this logic 30, 60, 90 by extending BA and CD. Everyone, any doubts? Because this is the key. If you have understood this, then this question will be solved. Okay, fine. Now again, observe triangle EBC. Now if this is 30, angle E is 30, angle B is 90, so angle C has to be 60 degree. Again, this is also a 30, 60, 90 degree triangle. and side opposite to 60 degree is of length 22 plus 2. So if I write it here, 30, 60 and 90, side opposite to angle 60 is of length 24. So side opposite to angle 30 will be 24 by root of 3. So this will be 24 by root of 3, which is 8 root 3. Is this part clear? Yes, no? ठीक है, बस हो गया काम. Now you have to find the value of AC. So apply Pythagoras theorem in this triangle, triangle ABC. In triangle ABC, apply the Pythagoras theorem. You'll get that AC square is equal to AB square plus BC square, which is AB is 2, so it will be 2 square, which is 4, plus this will be 8 root 3 square. So 8 square is 64 into 3, that is 196, or AC square is, sorry, this will be 192, the sum will be 196. So it will be 196, or the value of AC is 14 centimeter, or just 14. Now it says that the area of the triangle PQR, the largest triangle which we can see in the figure, is 36 centimeter. The point S is the midpoint of PQ. So PS will be equal to SQ, and ST and UR are perpendicular drawn on PR, and we have to find the area of triangle PTU. So this is the triangle for which we have to find the area, correct? Now can I say that STRU, it's a trapezium? Please respond, guys. Can you hear me? Okay, fine. So you agree that it's a trapezium, right? Okay, and what is the area of the trapezium? It is the sum of the opposite sides, opposite parallel sides, half of the sum of the opposite parallel sides multiplied by the height between it, right? Okay. Apart from that, we also know that, or let me just do one kind of one construction here. I have to join S with R. If I join this S with R, so what I mean to say is that the, and say this point is O, this point is O. So what I mean to say is that the area of triangle SOU, that is this part of the triangle, will be equal to area of triangle TOR. These two area will be equal. I am saying the triangle SOU, the area of triangle SOU will be equal to area of triangle TOR. Okay, let me explain this part, that why the area will be equal. In any of the quadrilateral, if you join the diagonals and say the area of this part is A and this is the parallel sides, and the area of this triangle is B, the area of this triangle C, and the area of need not to be parallel, sorry, yeah? This is just any quadrilateral, and the area of this is D, then we have a very good relation that area A into area B is equal to area C into area D. It's a very important relation. Direct questions appear in this. Fine. And if this quadrilateral happen to be a trapezium, then if this is A, this is B, this is C, and this is D, this relation will hold. Apart from that, the area which is not within the parallel lines, or the area which is not formed by the parallel lines, will be equal. That is, C will be equal to D. I don't have time to explain that, but it will happen. So just remember these two things. So coming back to this, with the same logic, if this is parallel, so what will happen is that this area will be equal to this area. So effectively, for triangle PTU, or the area of triangle PTU can be written as area of triangle PSR, because if I substitute this part, replace this part with this, then the asked question will reduce to this. Clear? Now S is the midpoint of PQ, and since S has been dropped perpendicular, and in PUR this part or the area of this part will be half of the complete largest triangle PRQ. Why? Because the base is same, and because this is the midpoint. If I drop it here, and if I drop the height from Q on PR, you will find that this length will be double of this, because S is the midpoint. This is the midpoint theorem. If I join the midpoints of two sides, then this side will be parallel to the third side and will be half of it. So because the height is half of the original triangle and base is same in both these triangles, the area will be half. So the straight away the answer will be half of this value, that is 36. So the required answer is 18 square units. Now for this question it's very easy. If you want to manipulate, the answer is straight away. The side is 15, right? So area of the square will be 15 square. Now nothing has been mentioned about the area or the dimension about this smaller square. It just says that it's just any of the square. Since nothing has been mentioned, so I can manipulate, or I can assume that this smaller square has a dimension 0. So what will happen, that G will reduce and will coincide with point D, E will reduce and coincide with point D, F will reduce and will coincide with point D. So you will see that the required area will be half of the square straight away. So the answer will be half of 15 square. This will be the answer, if you manage to do this manipulation. If not, then directly what you can do is that I'll quickly just give you the logic. So this is square, something like this, okay, and this was drawn, this was drawn. So this is the diagonal of a square. If I draw another diagonal, both will have 45 degree. So I can say these two will be parallel. So this part will be a trapezium. Fine. So area of this part will be equal to area of this part, with the same logic which we have done previously. So I can substitute the area of this region, or I can just take this region, the area of FHA, and put it here. So what will happen is that this area, once we put it here, it will nothing but the area of ADC, which is half of the square. Clear? So guys, should we solve? I think question number 15 is manageable now. It's nothing but an extension of the previous question which we solved. We have to use that formula, that product of the area of the opposite triangles are equal. I hope everybody got the answer for question number 15. Please respond. The answer should be 18. Right? It basically the same thing, right? It was something like this, and it said that one of the area is 12, another is 27, and these two will be parallel, because it is given that these two are, the area of these two triangles are equal. So if I assume it to be x, it will be x into x, which is x square is equal to 12 into 27. If you solve, you will get the answer to be 18. Correct? And this question actually appeared in 2008 ZAT. Right? So you can see the relevant of the logic. Fine? Okay, straight away we have very less time left. So I'll go to the question number 12. Anybody with any solution, any logic, how to solve this? Okay. Now what is given is that ABCD is a square E and S are the midpoints. So we have drawn a lot of diagonals and joining these midpoints with the what I said. So I've got this shaded region, and we have to find the area of the shaded region, or the ratio of the area of the shaded region with triangle ABCD. If you apply the plane geometry method, it's going to be very hard. So normally for such kind of question, whenever there is rectangle, square, or anything 90 degree, I usually apply the logic of coordinate geometry to get the answer clearly, right? I'll be applying the mix of both, in fact. So what I'll assume is that let this point be the origin. So if this is origin, and let me take the side to be 12, so this will be 12 0. Similarly, this part will be 12 12, and this part the coordinate will be 0 12. Correct? E is the midpoint, so this will be 0 6. F is the midpoint, so it will be 12 6. Correct? P is the midpoint of DB and AC also. So straight away the value will be 6 6. I hope this is easy to get. Don't have to solve any equation for it. Yes, no. Is this part clear till now, everyone? I have assumed the side to be 12. You can assume anything. You can assume 1 also. That's not a problem. Guys, am I audible? Or have you able to understand till now whatever have been done? Okay. Now, again, at R, point R is the midpoint of DF or CE. Because of the symmetry, I do not need to prove. So again, if you want to find the midpoint of this will be 6 3. Correct? Now, as observe the coordinates of P and R. The x coordinate is same, that is 6. Only the y coordinate is changing. That means P and R, if I join this line P with R, this will be parallel to AD or the y axis. This will be parallel to y axis. PR. Correct? Now I need to find the coordinate of S and Q. Now observe the triangle ESD. If you look at triangle ESD, this is similar to triangle DSC. Yes, no? Because between any two parallel lines, if you make any cross, then these two triangles are similar. Now the corresponding sides are in the ratio 1 is to 2 because ED is half of BC, right? So I can say that if I drop a perpendicular from S on ED, and if I extend or if I drop a perpendicular from S on BC, then this height will also be in the same ratio, and that ratio is 1 is to 2. The entire length is 12. So that should be the value of this part has to be 4 and the value of SQ has to be 8. Correct? Fine. Now, so this point is 4 distance away, so as Q 4 distance away from BC because of the symmetry. So the coordinate of S and Q, the x coordinate will be 4 here, and similarly the x coordinate of Q will be 4 from this place. So it will definitely, can I say that if this is 12, this is 4, this is also 4, so this part has to be 8. I'm talking about the x coordinate only, not the y coordinate. Is this part clear? You can find it. You can get the equation of the line and you can get the intersection. But that is not needed. Is this part clear, that the coordinate of x coordinate of s and q will be 4 and 8 respectively? Guys, please respond. Right? And from symmetry, it is very clear that if PQ is parallel to AD, then SQ, if PR is parallel to AD, then SQ will be parallel to DC. Everything is symmetrical here. Clear? So what I got is that the value of PR is 3. Why? Because the x coordinate is same, the y coordinate is 6 and 3 respectively. So the value of PR will be 3. Similarly, the value of SQ would be 4, because this is 4, this entire thing is 8. So the SQ will be 8, and these two will be perpendicular. Yes, no? So I got the value of SQ to be 4, PR to be 3, and these are the diagonals of SPQR. And if diagonals are at 90 degree, then we know that the area of the quadrilateral is half into of the two diagonals, that is D1 and D2. So straight away put the value, so it will be half of 3 into 4, which is 6. So the area of shaded region, so the area is 6 of the shaded region, and the area of the square, it will be 12 into 12, it is 144. Required ratio would be 6 divided by 12 into 12, or 1 by 24. This is the answer. So guys, as you can see, that application of coordinate geometry is very important. Of such question which has symmetry, 90 degree kind of things, you can definitely crack a hard question by applying coordinate geometry. So that's it for the day. I think we have done it for the 2 hours. I hope you all have enjoyed. Please subscribe to the channel which I just